Welcome to The Explainer. For years, we've pictured AI as this kind of disembodied brain just sitting in the cloud. But what happens when that brain actually gets a body? Well, that's what we're diving into today, the new era of embodied intelligence. This one question, it's driving this absolutely massive transformation in robotics. And this isn't just some sci-fi thought experiment. Nope. It's the spark for a change so big that analysts are talking about a potential multi-trillion-dollar market. That's trillion with a T. So for decades, robots were, well, pretty powerful, but kind of dumb. They just followed these rigid, pre-programmed instructions step by step. Now we're stepping into the age of embodied AI. We're creating intelligent systems that don't just follow a script. They can actually see, learn, and adapt from their own experiences in the real world. And the experts? They see this as way more than just an upgrade. It's a fundamental shift. AI is going from being a tool that works in the background to being the very engine of a whole new generation of robotics. It's really opening the floodgates for robots to be used across pretty much every industry you can think of.
Okay, so what's actually under the hood here? What are the specific technologies that are making this new era even possible? Let's break down the 6 key pillars that are really the engine of modern robotics.
Our source material really lays this out beautifully with what it calls 6 foundational pillars. You can think of them like a set of building blocks. Each one gives a robot a specific, almost human-like skill. But when you put them all together, that's when you create something totally new. First up, Pillar 1, computer vision. This is what basically gives a robot the sense of sight. It lets them see and actually understand the world around them. Recognizing objects, sorting different items, even reading a barcode in the middle of a chaotic warehouse.
Next up is natural language processing, or NLP for short. Now, this pillar is all about communication. It's the difference between having to type out rigid lines of code and just being able to say, hey, pick up that red box, and having the robot actually get what you mean.
The third pillar, reinforcement learning, is all about learning by doing. It's pretty cool. A robot tries something, it sees what happens, and then it tweaks its approach for next time. This is absolutely critical for things like planning movement and adapting to environments that are always changing. Pillar number 4 is supervised learning. This is how we turn a general robot into a real specialist. By feeding it tons of labeled data, we can train it to do incredibly specific things with amazing accuracy, like spotting a defect so small a human would never see it, or even predicting when a machine is about to break down.
All right, Pillar 5, Sensor Fusion and SLAM. And SLAM stands for Simultaneous Localization and Mapping. It's a mouthful, but it basically gives a robot its sense of space. It combines data from different sensors, like cameras and LiDAR, to build a map of its surroundings and know exactly where it is on that map. Super important for navigating a busy factory floor without bumping into things.
And finally, the pillar you've probably heard a lot about lately, generative AI. And let me tell you, this one is a true game changer. It lets a robot problem solve on the fly. It can actually generate its own code to figure out how to do a task it's never even seen before, all based on a simple command from a person. Okay, so that's the tech behind it all. It's powerful stuff for sure, but where are we actually seeing it get put to work? Let's take a look at the industries that are really on the front lines of this whole revolution. The first, and probably the biggest area, is the huge world of logistics and warehousing. These places are basically the perfect testing ground for intelligent automation. So what's driving it all? Well, it's a mix of sky-high consumer demand and a whole lot of investment. And in these warehouses, technologies like computer vision for sorting and that SLAM we talked about for navigation, they're essential for making our supply chains way more efficient and a lot more resilient. Next up is manufacturing. This is a sector where precision, speed, and quality are everything. So you can see why AI-powered robots are a perfect match here. Companies are using these robots to streamline really complex operations and just dramatically boost their quality control. This is where that supervised learning really shines, spotting tiny defects in everything from car assembly lines to making sensitive pharmaceuticals. And hey, it's not just about warehouses and factories. These intelligent robots are now making their way into the service sector, changing how we interact with businesses every single day. A huge driver here has been rising costs and, let's be honest, major labor shortages. So now you're seeing restaurants and other businesses use robots for the repetitive stuff, like being a server or kitchen helper. And this actually frees up the human staff to focus on the customer experience, that all-important personal touch. So with this tech already out there and making a real impact, the next logical question is, where does it go from here? What's the near future going to look like for embodied AI? The next big leap is this idea called physical AI. The concept is actually pretty simple, but it's incredibly powerful. Instead of trying to program a robot for every possible situation, you let it train for millions of hours inside a virtual simulation. This lets it learn safely and super quickly from experience before it ever even touches a real-world object. And look, this isn't some distant science fiction. This timeline from our source shows a really clear path. We're in early adoption right now. We hit a growth phase around 2027. And by the early 2030s, this stuff is expected to be mainstream, widely adopted technology. So what's going to drive that rapid adoption? Well, no surprise here. It comes down to a clear and very compelling financial reason: a faster return on investment. Companies that invest in these AI-integrated robots see their money back faster because, well, the systems are just plain better. They're more efficient, they make fewer mistakes, and they can even predict their own maintenance needs. That reduces costs all across the board. And all this brings us to our final thought. This whole technological shift, it isn't just about building smarter machines. It's about creating a totally new kind of collaboration. As AI gets a body and starts moving around in our physical world, it leaves us with a really fundamental question to think about. What is our partnership with this new form of intelligence actually going to look like?